Welcome to this video. So in this video, we'll be looking at questions from tutorial sheet 4. So tutorial sheet 4 is basically on stoichiometry and chemical reactions. Okay. So you see that on question 1, we're going to be balancing chemical equations. Question 2 will be applying Henry's law. Question 4, okay, we'll be looking at how to find the molarity of the solution. Okay, question 3 and 5 will just be on how to use the mole ratios, limiting reactants, and how to find the percentage yield. Okay, so these are the questions that we're going to solve in this video. Okay, so let's start with the first one, which is on balancing chemical equations. Okay, so I know you already have some knowledge on how to balance chemical equations from your grade 12. Okay, so here now at university level, we're just going to make it more systematic so that it's actually easier to balance these chemical equations by just using intuition. Okay, so when we're balancing these chemical equations, we're first of all going to balance, okay, balance any other atom apart from, okay, any other atom apart from oxygen, okay? So let me write apart from oxygen and hydrogen. So in any chemical equation that you are going to be given, first balance the any other atom that you have apart from the hydrogen and the oxygen, okay? And then step 2 now, we're going to balance the oxygen and, okay, we're going to balance oxygen and hydrogen. Okay, so here it will be depending on which one is simpler. Sometimes you can start with balancing the oxygen and then you balance the hydrogen later, or you can start with balancing the hydrogen and then you balance the oxygen later. Okay, so it actually tells you that you have to practice on more questions so that you'll be identifying those key features. Okay, on which one can I start with? Okay, because here we're just balancing by what? Intuition. All right, but there are standard methods of balancing this. Later on, you're going to learn the electron method, okay? So those are standard methods, but here we're not using those, we're just using intuition. Okay, so let's start with the first one. So the first chemical equation is C4H10 plus O2, okay, and then this produces carbon dioxide plus water. So here we see that we have carbon, oxygen, and hydrogen. So we start by balancing the carbon. So on my left-hand side, I can see 4 carbons there, but this side I can only see 1. So what do I do to balance it? I add a 4 here. Okay, so the carbon has been balanced, and then from there we can go and balance the hydrogen. Okay, so on my left here, you can see that how many hydrogens do I have? I have 10, and then here I only have 2. So what do I need to do to these 2 hydrogens to make them 10? I just add a 5 in front. So this means I have 10 hydrogens now there. Okay, so I've balanced the hydrogens and I've also balanced the carbon. So the only remaining thing now is the what? The oxygen. So when I come on my left here, I only have 1 oxygen. I only have 2 oxygens here. These are 2. Okay, I only have 2 oxygens here. When I come on the right, I have 4 multiplied by 2. So this is 8 oxygen plus here I have 5 multiplied by 1 oxygen, which is just 5 oxygen. So it means on my right hand side, I have a total of 13 oxygens. Okay, and then here I have 2 oxygen. So what do I need to do? Okay, to make these 2 oxygens to be equal to 13 oxygens. Okay, I can just multiply by, I can multiply these 2 oxygens by what? I can multiply them by 6.5. Okay, so now take a look at what is going to happen. So if you multiply 2 multiplied by 6.5, you're going to get 13. So that's what I'm going to do here. Okay, so I'm going to write this equation in the following way. Okay, I'm going to say, okay, I have CH4 here. I have C4 and then H10. Okay, and then to these 2 oxygens, to make them 13, I want to multiply by 6.5. And then O2 is equals to 4 CO2 plus 5 H2O. Okay, so it means this equation is balanced. Okay, we have 4 carbons on both sides, we have 10 hydrogens on both sides, and we have 13 oxygen on both sides. But now the issue here is this decimal number here. Okay, a decimal number is not allowed when you're balancing chemical equation. So how do we get rid of this decimal number? We're going to multiply throughout here by a 2. Okay, because I know that 6.5 multiplied by 2, it's actually going to give me 13. Okay, so you multiply by 2 throughout here. So it means we're going to have 2C4H10 plus 6.5 multiplied by 2, that is 13O2. And this gives me 8CO2 plus 10H2O. Okay, so now this equation that I've written here is balanced. Okay, you can confirm we have 8 carbons there, 2 multiplied by 4. In here we have 8 carbons. Okay, we have 2 multiplied by 10 hydrogens, so this is 20 hydrogens. Even here we have 10 multiplied by 2, that will give me 20 hydrogen. And then the oxygens here I have 13 multiplied by 2, so that will be 26. Okay, and then here I have 10 of the oxygens from the water, and then from here I'll get 8 multiplied by 2, that will be 16. So 10 plus 16 gives me what? 26 oxygens. So this one here is the correct balanced chemical equation for the first one here. Okay, so you are seeing there, we're just using intuition. Okay, so now let's balance B. Okay, so B is very simple. So how do we balance B? So B, we have N2H4 plus N2O4, and then this is producing N2 plus H2O. Okay, so let's look at the atoms that we have. So we have nitrogen, hydrogen, and oxygen. So we balanced any other atom apart from the oxygen and the hydrogen. Okay, so here we see that I have 2 nitrogen, 2 nitrogen. So it means on my left, I have 4 nitrogen. On my right, I only have 2. So to balance it, what do? I add the 2 here. Okay, so the nitrogen is balanced. And then from there, I'm going to balance my oxygen. Okay, so here I only have 4 oxygen. Here I only have 1 oxygen. So what do I do there? Okay, I'm going to add a 4 in front of that water so that I have 4 oxygen as well. So I'm going to add a 4 here. So this means I have 4 oxygen. Even here I have 4 oxygen. I have 4 nitrogen here. Even there I have 4 nitrogen. So now we can try to balance or see if the hydrogen is balanced. So this here simply means that I have 8 hydrogens, but here I only have 4 hydrogens. So what do I do to the 4 to make it 8? Okay, I multiply it by 2. So I'll put a 2 here. So immediately I put a 2 here, it means everything changes there. Okay, because this 2 will require that I have, will mean that here I have 2 multiplied by 2 nitrogens. So I have 4 nitrogens plus from here I have 2 nitrogens. Okay, so 2 nitrogens. So it means on my left, I have 6 nitrogens there. Okay, but here I only have what? 4. So what can I do to this to make it 6? Because I already have a 2 there, I'll just change the coefficient here to what? To 3, like that. So now I have 6 nitrogens there. Okay, I have 8 hydrogens, and the number of oxygen is also balanced. So if I can write it cleanly here to be like this. So 3N2 plus 4H2O. Okay, so you have to put in some thoughts for you to get the correct balanced equation. So you can check here. So 4 nitrogens here plus 2, that will give me 6 nitrogen on the left. And then on the right, 3 multiplied by 2, that's also 6. Okay, for the oxygen, I only have 4 here. Even here, I have 4 multiplied by that oxygen. So I have 4 oxygens here. Okay, even here I have 4 oxygens. The hydrogens, I have 4 multiplied by 2, that would be 8 hydrogens. Even here I have 2 multiplied by 4, that would be 80 hydrogens there. Okay, so there I'm supposed to write 9 hydrogens. So it means this one here is the correct balanced chemical equation on number what? 2. Okay, so now on number C, we see that we have some special groups. So So those special groups are called radicals. So it's better when you're balancing the radicals, you just consider the whole radical as one molecule than considering them as individual molecules. Okay? Because you're going to get in trouble. So here we have, look at this, we have Fe2O3 plus HNO3, and this gives me Fe and then NO3 3 plus H2O. So we're going to be taking, okay, we're going to be taking this group here as one thing. Okay, this group here, we're going to be taking it as one thing. Because if you consider it individually, okay, it's going to be hard for us to balance this chemical equation. Okay, so that's just the nitrate there. So the nitrate is a radical. So we're going to be considering it as a one when we're balancing this. Okay, so the first thing we said was to balance the what? Any other atom apart from the oxygen and the what? And the hydrogen. Okay, so remember we're taking this thing here as one thing. Okay, so let's balance the ion first. So here on my left, I have two of the ions, and then here I only have this one. Okay, so what can I do to balance the F or the ion? I'll just add a two here. Okay, so I have two ion here, two ion there. Okay, and then from there, we need to balance this group now, this group here. Okay, the nitrate group, even this group, the nitrate group. So we see that on my left, this side, I only have one of these groups here. This is just one. And then here, I have these three being, I have three of them, then I'm multiplying by two. So it means here I only have one. Here I have how many? Two multiplied by three. So I have six of these. Okay, I have six of these. So what can I do in order to balance? Since here I have six of this group, remember we're considering it as one group here. So 2 multiplied by 3, that is 6 of these. So I'll just add a 6 in front here. So it means now here I have 6 of these guys here. Okay, so once I balance them, I can now check it. I can now check if the oxygens and the hydrogens are also what? Are also balanced. So let's check the oxygen. Okay, let's check the oxygen. So when I go to this molecule here, so remember, I'm not considering the oxygen of here because this one, I'm taking it as one group. Okay, so I'm just considering the oxygen there and the oxygen here. Okay, so we're going to say that in this first compound here, how many oxygens can you see? I can see 3 oxygens here, 3 of them. Okay, and then here I can only see what? 1 oxygen. So what am I going to do? I'm going to add the 3 here. Okay, so it means 3 oxygens, 3 oxygens. So the oxygen have been what? Have been balanced. And then now you also check if the hydrogens have been balanced. Okay, so here I have 6 of the hydrogens because it's 3 multiplied by 2. And then even here I have 6 hydrogens. So the hydrogens have also been what? Balanced. Okay, so if I can write it in a clean form, it will be Fe2O3, okay, plus 6 HNO2, and this gives 2 Fe, okay, 3 plus 3, like that. So everything there is now what? Balanced. Okay, so you see that it's very easy to balance this if you consider this as one thing. Okay, so if you consider it as different things, it's going to be very hard to balance. So once you've balanced it, considering as one thing, you can even confirm now individually if you have the correct numbers. Okay, so for the ion, I have 2 here, 2 there. For the oxygen, I'll have 3 here, and then from here, I'll have 3 of the oxygen multiplied by 6. So that would be like 18 oxygens. Okay, so 18 oxygen from here plus 3, that is 21 oxygens. So let's confirm we also have 21 oxygens here. So I have 3 there. Okay, and then from here, I have 2 multiplied by 3, that is 6. 6 multiplied by 3, that is 18 of the oxygen. So I also have 21 oxygens. Okay, and then the nitrogens, I have 6 of them there. And then even here I have 6 because there's these 2 being multiplied by these 3, and then there's a nitrogen inside here. So that is 6 nitrogens. Okay, and then even the hydrogens. Okay, I have 6 of them, even they have 6 of them. So we have balanced this chemical equation here. Okay, let's look at the last one. So the last one is very easy, as you are going to see. It doesn't require much of the thinking. So we have P4O10 plus H2O, and this gives me H3PO4. So we said we first have to balance any other atom apart from the hydrogen and the oxygen. So we see here that here I have 4 of the phosphorus, or 4P, okay? And then here I just have 1 of it because this is just 1. This 4 is on the oxygen, so I just have 1 of it. So what do I do in order to have 4 sulfur? Okay, I mean 4 phosphorus even on this side, or 4P. I just had the 4 here. Okay, so if I add that 4, it means I have 4P, even here I have 4P. So the P's have balanced. Okay, so from there now, I can balance the what? The oxygen. Okay, so let's try to balance the oxygen. So here I have 10 plus 1. So here I have 11 oxygen, okay, on my left. And then here, our 4 multiplied by 4 oxygen. So it means here I have 16 oxygens. So what can I do to this 11 to make it 16? So since here I have 10, I can just add the 6 here. So if I add the 6 there, it will be 6 oxygens plus 10 oxygens. Even this becomes 16 oxygens. And even on the other side, it also 16 oxygens. And then you also check if your hydrogens are what? Are balanced. So the hydrogens here, it is 6 multiplied by these 2. So I have 12 hydrogens. Okay, here it's 4 multiplied by 3. It's also 12 hydrogens. So you've seen that this one is very simple. Okay, so it means P4O10 plus 6 H2O and then 4 H3 PO4 is the correct balanced chemical equation for the last one. Okay, so we are basically done on question 1. Okay, so now let's look at question 2. So question 2, they're saying the solubility of nitrogen in water is 8.21 times 10 to the power minus 4 moles per liter at 0 degrees Celsius. That is when the pressure of nitrogen, uh, that is when the nitrogen pressure above the water is this, okay? And then they're saying calculate the Henry's law constant. Okay, so here, since we are using Henry's law states that the concentration, okay, or in other words, the solubility is equals to the Henry's constant, Kh, multiplied by the partial pressure. Okay, so this C, I've already said it's a concentration or the solubility of this gas in water. Okay, this Kh is the Henry's law constant that we want to calculate. And then this P is the partial pressure of the gas above the liquid. Okay, so in this case, we have been given that the solubility is this. So it means our C is just 8.21 multiplied by 10 to the power minus 4. Okay, and then the partial pressure, we've been told it's 0.790 atmospheres. So we just have to calculate the Henry's constant, this guy here. So we just put these into the formula there. So we are going to say 8.21 times 10 to the power minus 4 is equals to, so Henry's constant multiplied by the partial pressure. Okay, so it means here we just divide both sides by this car. Okay, even here we divide by this same thing. So it means Henry's constant is equals to, okay, this guy multiplied by this number here divided by that. Okay, what will it give us? So I'll just punch that onto my calculator. Okay, so it's giving me approximately 1.04 multiplied by 10 to the power minus 3. Okay, so this here will be my constant. Okay, so sometimes they'll ask you for the units. Okay, so this, remember the concentration was moles per liter, this guy here, and then this guy is atmospheres. So it means the Henry's the net zero constant has what units? Okay, so the unit will just be moles per liter, okay, and then multiplied by the atmospheres. So these will be the units there. Okay, so we've answered part A, where we're calculating the N zero what constant for this specific gas, which is nitrogen. Okay, so you just have to master this formula here. So from there now, they're telling us to, they're asking us to do what? Okay, so from there on B, this is B now, they're saying calculate the solubility. Solubility is the C, okay, of nitrogen in water when the partial pressure of nitrogen above water is now 1.1 atmospheres. So we have the constant. Okay, so maybe I should write the formula first of all, KH multiplied by the P. So the constant is what we found here, multiplied by 10 to the power minus 3. Okay, so I'll multiply this by the partial pressure now, which is the new one here. So 1.10. Okay, so we just punch this onto the calculator and then you get your answer. Okay, so approximately I'm getting 1.14 multiplied by 10 to the power minus 3 moles, okay, per liter. So this one here will be the concentration if the partial pressure is what? 1.10 atmospheres at 0 degrees Celsius. Okay, so we are done with question 2. All right, so thank you so much for watching this video. If you'd like to access the full solutions to the video, they are available on our website, okay? So on our website, we also have full video solutions to all the tutorial sheets that you've had so far and all the tutorial sheets that you have. So this was tutorial sheet 1, okay? You can see we have the full video solutions on our website. This here is tutorial sheet 2, okay? We have full video solutions on our website. You can watch and learn anytime. Tutorial sheet 3, okay? We have full solutions on our website. These are the questions here from tutorial sheet 3. Tutorial sheet 4, you can see all these questions. We've solved them. The videos are there on our website. Tutorial sheet 5. Okay, we've solved all these questions and the videos are there on the website. So you can learn at any time at your own pace. We have explained all these videos in a very clear manner. Okay, so once you register and then you go on our website, you are going to see something like this. Okay, so this is our homepage on our website. So you just scroll down here, you're going to find the courses. So depending on the courses that you've enrolled for, you have enrolled there on the course if you've paid for it. Okay, so these this tutorial sheet, it was for chemistry. So if you want to access it, okay, as you are preparing for your test 1 exam or quizzes, okay, you just go on open course here for the chemistry. So you open the course, it's going to bring 2 folders. So there's general chemistry and bio and organic chemistry for those who are doing second semester at Apex. So since you're in first semester, okay, or if you're from any other university, you go in general chemistry. Okay, so in general chemistry, you're going to find about 5 folders. So here in the last folder, we have some lab report samples. So as you're going to do your labs, we have some samples here that you can check, and then you get to have an idea or have to do the labs. Here we have the lessons and tutorials on each and every topic that you learn in the chemistry course. So if you open these lessons and tutorials, okay, you'll see that here you're going to have all the topics, okay, listed that you learn in chemistry. So introduction to chemistry, whatever you're going to learn, we've explained fully all the topics, okay? There are notes there and there are videos there you can watch at your own time, all the way to nuclear chemistry, if you're taking nuclear chemistry, okay? Once you leave this folder for the lessons and tutorials, you go back here. Okay, so once you're back here, you can see here we have handwritten summarized notes. So on all the topics, we have handwritten, well summarized notes if you want to read the handwritten notes. And they are very funny and they're very direct to the point. So you can also read them. Okay, if you want solutions to the assignments or tutorial sheets, you come to this folder here. Okay, so you open this folder for the assignments and tutorial sheet. Then depending on the university where you are at, okay, you'll find that folder. So this tutorial sheet were for the Apex people. Okay, so you can go to the Apex folder. Okay, and then you go to your intake. So in the January 2024 intakes, we also have full videos there. So you can even use them to learn. The concepts are the same. In 2024 July intake, you can learn still. In 2025 July, January intake, there are full videos there for all the tutorial sheets you can learn. So for you, who is 2025 July intake, you come to this folder. You're going to find all those videos on all those what? Tutorial sheets. Okay, so you even use the videos for the past intakes, okay, because the concept are the same. So you can go in this folder, you learn all the tutorial sheets are solved here from tutorial sheet 1 all the way up to tutorial sheet 14 when you go to January 2025 here. If I open it, okay, and you go to the video solutions, we also have written solutions there, okay. You can see all these videos all the way from tutorial sheet 1, the assignment 1, the assignment 2, all the way to tutorial sheet 13, okay. So you can learn at your own time. Okay, it is a very good portal. And then here also have written solutions, you can access them. So if you open here, you're going to find the written solutions. So this was for the January intake. So you can see all these written solutions, they are just waiting for you. Okay, so that's how you can access the tutorial sheets or the assignments. But if you'd like to access the past papers, okay, then it means you have to go to this folder here for the past papers. So you're going to find quiz papers there, solved videos, and there are also some written solutions. So you go to Apex. Okay, you also find videos on exam papers. So if I go to the videos there, you see that there are videos there for some exam papers, for some tests, for some quizzes. Okay, you can access all these and learn at your own time to prepare for your what? For your exams. Okay, so I hope you enjoyed the video. Thank you so much. If you'd like to register for our lessons, okay, just see the link in the description below. Okay, it has a link to our website. It has a link to the registration guide video. So you watch that video on how to register on our website, and then you can register and you can start learning at your own time. Okay, otherwise, thank you so much. This has been Tutor Post Solutions. For any questions, please reach out to me using the numbers in the description below.